So today in Algebra 2, we're going to start Chapter 11. We're starting with Section 11.1, which covers statistical questions and variables. Our Chapter 11 essential question: what questions can you answer by using statistics and normal distributions? 11.1 essential question: what kinds of questions about quantities and relationships among quantities can be answered with statistics? After today's lesson, you should be able to use vocabulary related to statistical questions and variables. So let's start out with some vocabulary. A statistical question, okay, so we're going to start out with a statistical question, can be answered by collecting many pieces of information or data and then summarizing the data. A statistical variable is a quantity or quality that can be measured or counted and for which the data is expected to differ from one observation to another. There are two main types of statistical variables. Those are categorical and quantitative. Data that fall into categories or that indicate a qualitative rather than quantitative attribute represent a categorical variable. So this is data that you can put in some type of category. Numerical data, so has numbers that in the context of the data can be compared, added, subtracted, or otherwise operated on, represent a quantitative variable. The set of all members of a group that you want to know something about is called a population. A sample is a subset of the population that is being studied to answer a statistical question about the population. So the population, that's the entire thing. If you only pick out a few of that population, that is referred to as the sample. A statistic is a measure that describes a sample of the population. A parameter is a measure that describes the population itself. So let's look at some examples. Number one, a state questioned some of its high schools about the price they were charging for prom tickets. The results are summarized in the histogram. Remember, a histogram is just a fancy word for bar graph. So here we have prom ticket prices. We have the number of schools that were interviewed and the individual ticket cost. So what questions could be answered using that data? We could answer, what is the median cost of a prom ticket? So what is the median cost of prom tickets? We could answer that with this graph. We could answer, what is the range of cost for prom tickets? Those are just two questions that we could answer using that data. And then who might be interested in the answers to these questions? Obviously, the students might be interested, right? Their parents might be interested. The administrators at schools might be interested. The state itself might be interested to know how much schools are getting from prom tickets. And then it says, Shelby is surprised that the median cost of a prom ticket is not higher, since her school is charging $60 per ticket. What are some possible reasons for this? Her school is more expensive, right? It's just her school, one of the more expensive. I would say there was a higher proportion of schools with a lower cost for prom tickets. Right. we're going to consider the following questions. Question number 1, in what month is your birthday? Question number 2, what month has the most birthdays of students at your school? Okay, so let's talk about question number 1 first. So question number 1, this can be answered with only one piece of information. You only have one birthday, so if I ask you your the month of your birthday, you're only going to give me one answer, 1 month. Question 2, on the other hand, you're going to have to collect many pieces of data. And summarize those. Question 2, since we are collecting data and summarizing it, is a statistical question. Question 1 be like an interview question asked to get info for question 2. Okay. So now let's look at a graph, and it says, does each graph represent the answer to a statistical question? Okay. So we'll talk about this first one, the distance traveled to school. They gave us the student age and the distance in miles. Okay. This is a scatter plot, so let's just remind ourselves that this is a scatter plot. And it shows answers like possible question. Okay. The possible question asked to get this is, how far do you travel? To get to school? That could be a possible question answered to get this. They gathered information and they summarized it in the graph. That is the definition of a statistical question. So yes, statistical question. Let's look at graph number 2. We can see by looking at this, this is a linear graph. So what would be the possible question asked here? We see that it's the travel time at 20 miles per hour with the average speed. Okay? So they give me the distance and the time. So possible question here, how long does it take? So how long does it take to travel, let's say X miles at 20 miles per hour? This has a predetermined answer. For each X, there's only one Y value. Okay. So this is not anything that I can gather a whole bunch of data and then summarize it, because each individual X value is going to have only one Y value. It's not going to change. So therefore, this is not a statistical question. Okay. So number 4, is the given question a statistical question? Okay. Again, remember, we're looking at, can we gather a bunch of information, bunch of data, and summarize that data? Okay. Well, there are lots of different possible answers that we could get from the question and then summarize all of that together. So A, which is the most popular visual art form? Photography, painting, sculpting, or drawing? Would we be able to get different answers from this question? Yes, depending on who we asked. Right? Not everybody that we interview are all going to have the same answer. So yes, this is a statistical question Because there are going to be many possible answers. So we could get many possible answers, and then we could summarize those answers. B, how many lithographs were created by the artist N.C. Escher? Can we get more than one correct answer? No. Okay? This is not a statistical question because there is one definitive answer. So now we're going to move on to statistical variables. It says, what type of statistical variable is represented by the following question and chart? Remember that our two types of statistical variables are categorical or quantitative. So categorical, remember it falls into a category. Quantitative, it has a numerical value associated with it. So it says, what is your favorite summer Olympic sport? And so then we see the charts. We had 25% for track and field, 25% basketball, 20% swimming, 30% gymnastics. So this is a categorical variable. Because it has data that falls into categories. Our answer was not a number, okay? What is your favorite summer Olympic sport? Track and field, basketball, swimming, gymnastics. Those answers are not qualitative. Those answers are not numerical. Right. Part B. What is the typical number of apps a teenager has on a smartphone? And then this is the graph that they give to us. What type of data are we getting here? These are quantities, right? Not categories. Therefore, this is a quantitative variable. Again, this is numerical data. Numerical data is quantitative. Right, example number 6. What is the statistical variable represented by each of the following questions, and is it categorical or quantitative? A, what breed of dog is most likely to be adopted from an animal shelter? Breed of dog, are we going to have numbers there, or are we going to have categories? We're going to have categories like Rottweiler, Doberman, German Shepherd, Poodle, right? So we're going to have categories. So this is going to be, first it said, what is the variable? So the variable is the breed of dog. And then what type is going to be categorical because it falls into a category. B, what is the average number of students per activity participating in after-school activities at Branson High School? What is our variable? The average number of students participating in after-school activities. So that's our variable. Is that going to fall into categories? No, it didn't ask me what type of activities they were participating in. It asked, what's the average number? How many? That's going to be a number. So this is quantitative because this is a numerical data. Okay. All right, number 7. The school newspaper randomly selects 30 students from each grade level to participate in a survey, I should say, to determine the opinions of students at the school. What is the relationship between the sophomores surveyed, all the students surveyed, and all the students at the school? So remember, this is where we talked about like the population and samples. Okay, so first let's talk about what is the population. The population would be all the students at the school. Right? So all students at the school are the population. Then we have sophomores. Okay, sophomores, that's just a small part of all of the students. So that's a sample, because a sample is just a little part of the population. So sample are the sophomores. The sophomore class would be a sample of the population. But then students surveyed, well, they only selected 30 students from each grade. So also, students surveyed would also be a sample here, because that's so many people from the entire population. So that's why it's a sample. So what's the relationship? Both the sophomore class and all students surveyed are samples of the population. The population is all the students at the school. Number 8, a polling organization randomly chose eligible voters in the state of Illinois to ask who they would vote for in an upcoming election for governor to determine who will win the election. What are the sample and the population in the scenario? Population, we'll start with that, okay? The population, that's the large picture. Population would be all eligible voters in Illinois. All eligible voters in Illinois. That's our population. Our sample are the randomly chosen eligible voters in Illinois. So the ones that we surveyed. Okay. Number 9, a city worker collects 5 vials of water from each of 10 randomly selected locations all over the city to test the levels of bacteria in the city water supply. What is the sample and the population? Again, I like to start with population, the big picture. The population is the city water supply. Okay, so all city water supply. So all the city water supplies. Okay. The sample, well, out of all the city's water supply, how much did they pick? They took 10 randomly selected locations. They collected 5 vials from each. So 5 times 10, the 50 vials of water collected. That's our sample. Okay. Next, number 10, it says, is each quantity a statistic or a parameter? So let's recall what those are. Remember, a parameter is a measure that describes the entire population. A statistic is a measure that describes a sample of the population. So a high school has 3 lunch periods. In a randomly selected lunch period, 24% of students brought lunch from home. So first, let's talk about what is the population. The population is all students, right? Did they survey all students? No. Randomly selected lunch period, okay? They have 3 lunch periods, so they only took 1 lunch period. And in that 1 lunch period, they took a sample, right? So they took a sample from 1 lunch period. And in that 1 lunch period, 24% of students brought lunch from home. Since they only looked at a sample of the population, that is a statistic. So therefore, this is a statistic. B, at the end of its first year of business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales and the number of tickets sold to calculate the mean amount spent at concessions by a moviegoer was 814. Is this a statistic or a parameter? Okay. They looked at the entire population, right? The population are all moviegoers. They used the total yearly concession sales and number of tickets sold. So they took into account all the moviegoers for that 1 year, the entire population. Therefore, this is a parameter because this talks about the entire population. So this is a parameter. Part C, 53.2% of a district's eligible voters voted for the sitting U.S. House representative. The population are eligible voters, right? We're talking about all of the eligible voters, 53.2%. Therefore, again, it's a parameter because they're talking about the entire population. All right, our last one. The median age of a car in 20 randomly selected spaces in the school parking lot is 7 years. The population, all parking spaces, right? Are they talking about all parking spaces? No, they took a sample of 20 spaces. So since they're dealing with a sample of the population, therefore this is a statistic. All right, so that wraps up section 11.1 on statistical questions and variables. Your homework will be Envision assignment 11.1. So log into Envision and complete that assignment. I believe there are like 15 questions in there. And then tomorrow we will look at section 11.2.